Okay, before we go into the energy systems, I want to talk about ATP by itself for a moment, so that way you have a broad overview of what ATP is. So let's go ahead and draw that out. So we have ATP, which is like our chemical energy for the body. So I kind of think of it as kind of like gasoline for the body. And that is adenosine triphosphate. And that tri there is important. So you want to remember that because that refers to having 3 phosphates there. So let me kind of draw it out. So we have adenosine and 3 phosphates. And so if we want to get energy from this, we're going to have to hydrolyze those bonds to break a phosphate off. So if you're taking biology class right now, you may have heard of hydrolysis. And that's what's going to break that phosphate off, and that's going to leave us with ADP, so adenosine diphosphate. So 2 phosphates plus phosphate plus energy, which is what we're trying to release. So this over here would be stored energy. And this would be used energy. So this process can go back and forth. So if we want to get energy, we kind of have to break that phosphate off using hydrolysis, and that's going to release energy that we can use for work. It's also going to produce heat in the body, and that's going to leave us with ADP. So right here is ADP, adenosine diphosphate. So we have 2 phosphates there. It's going to leave us with a phosphate and some energy. And the stored energy that I referred to just a little bit ago is the same stored energy that we would use to get us started. So if we were about to start working out, for the first 2 seconds, we're going to run off that immediate source of ATP within the muscle. And so once we break that down, we've got to get our ATP stores back, and that's what's going to lead into the next video when we talk about the ATP-CP system. So using creatine phosphate and breaking that phosphate off creatine to replenish our ATP stores. So before we do that, I want to go a little bit further in this, and this is something that you won't have to use too often, but I at least want to introduce you to it on how hydrolysis works so that you can have at least a rough understanding of it. So what I'm drawing out here is a phosphate with some oxygens around it so that you can kind of see how phosphates are bonded together, and then this will help you understand how they are broken apart through hydrolysis. So once we have water come in here, so we'll have an oxygen here with 2 hydrogens. And what's going to happen is, since oxygen's a lot more electronegative than hydrogen, it's going to steal the electrons from this one and bind here, so that's going to help break apart these phosphates. And of course you'd have another phosphate here and so forth, and bound to a carbon anyway. That would eventually make up adenosine triphosphate, but I'm not going to draw all that out. That's a little bit further away from what we want. And so the big end picture here would be, you would have phosphates over here. So this is what this is going to look like once hydrolysis has occurred. So we have an OH here, and that's going to break that other phosphate off, and we can just pretend. So we have an OH here, and then this would be bound to the other phosphates, and I'm not going to draw it all the way out. Anyway, and that would go further and linked to the ribose sugar. This is the beginning here of the ribose sugar, because here's our carbon chain, and it would be 5 carbons. Anyway, I'm not going to draw all that out, but this is what it would equal up to. So we had water come in here and break that bond, and then this phosphates. Once that bond is released, we're going to have an energy release, and that's where we get the energy. So I hope this gives you a basic idea of ATP and how it's used in the body, and the major process that breaks that phosphate off, which is hydrolysis, and how we can use stored energy, and how once the energy is used up, how we can bring it back to stored energy. And we'll talk about that in the next video, and how we use creatine phosphate, which is also stored in the muscle, to help replenish the ATP stores. So I hope you enjoyed the video, and I'll see you in the next video series.